So I was wondering, Bobby, is there maybe another way of cross-checking our answer?
Because in this case, we are just finding out the current through
Correct.
maybe 10 ohm.
Yes. We have done problems like this when we were doing phasors and also maximum power transfer, things like that. We were interested in only one component, one resistor. We have done that.
Oh, so we have just removed that and then took a Thevenin equivalent of
Thevenin
resistor.
equivalent.
So that same approach should be valid here in
Should be
Laplace
valid.
domain also.
Correct. Correct. That's right.
We'll just cross check.
Let's cross-check it.
Oh, okay. So that means I will maybe just copy the Laplace
Yes.
domain this transformed circuit.
Yes.
Anyway, we are interested only in I2 of t.
Correct. So maybe you can just mark those two nodes and yeah.
AB.
Yes. And we are going to remove this 10 ohm resistor,
10 ohm
that is
resistor.
RL.
Yeah.
As far as we are concerned.
Correct. I think that way it will not work like this.
Maybe we'll just redraw it.
Yeah.
Yeah.
Oh, so that is better. That's correct. That will be a good revision for
Yes.
Thevenin also. So the step 1, we remove this, the
Correct.
RL,
Correct.
and find out VTH.
VTH. VTH is the open circuit, voltage. Correct.
Which is VAB.
VAB. Correct.
How shall we do? Oh, it's just the voltage across
voltage
10 ohm.
division. It's just the voltage across the 10 ohm because there is no current through S,
Correct.
the second right side
So I
inductor.
just have to get this voltage.
That's correct. And we know the ratio of impedances.
Yeah, so this is 100 by S divided by S plus 20
Yes.
into
10.
10.
Correct.
Okay. So that means
1000 by
S into S plus 20.
correct. Numerator is 1000. Correct. Correct.
Oh, VTH is
So this is VTH. Easy.
So this is VTH of S or something?
Yes, VTH of S.
Yeah.
Correct. And now we need to find out RTH. Or ZTH in this case.
ZTH. Yeah.
Impedance.
Okay. Okay, I don't have
Shall we go to the next page? We'll just go to the next page. We'll come back and write it here.
Yeah. So this is the step 2 where we replace this sources with its sources with their internal impedance.
With an internal impedance. So right now it's a short circuit.
It's because it's a voltage source.
Voltage source.
Okay.
And we find out Z. ZAB is what we want to find. That is also easy, seems like it's easy.
Yeah. So it's 10 and these are coming in parallel.
Correct.
So this is 10 into 10 plus S divided by S plus 20.
F plus 20 and then you add S in series.
Plus S.
Correct. This is ZAB. Very easy.
So set ZTH of S.
Yes, ZTH of S.
So should we take LCM or something?
Yeah, let's do that. We can take a LCM and do it.
So this will become S plus 20.
Yes.
So here I have, anyway, I will go step by step. 10
Yes.
into 10 plus S plus S into S plus 20.
Correct. So we can actually make things a little bit easier.
Easier? Oh, tell me.
So if you go back, we can you can go to the previous page. Maybe things will be easy if we find out the Thevenin equivalent, because this is ZL. Instead of taking 10 ohms as the L, it may be easier if we take S plus 10 as ZL.
Because we just
We
want
are
to
interested in the current.
Correct,
the current
correct.
is the same in
So
both.
the load can be S plus 10 also.
S plus 10 also. I think that may be easier, because you are now having a second order in the numerator
in ZTH.
in ZTH of S. You won't have that. You won't have this. So you'll just get this. Maybe a lot easier.
But finally it will come, no?
Finally it will come.
Because RTH is ZTH plus R plus.
Exactly.
Yes,
Finally, when you calculate the current, VTH divided by ZTH plus that, it will come. But solving for ZTH will become easier. You'll just get a simple S and S in the numerator and denominator. But we'll do like this, no problem. Let us just do like this. Our students can try out that way also.
That way also. Yeah. So this will be
S squared plus 30S plus 100 by S plus 20. So S squared plus 20S plus 10S, 30S plus 100.
Yeah.
This is correct.
Correct. And we want I of S.
I of S.
Or it was I2 of S. But here.
Correct. So maybe we'll go to the next page and draw the network with the Thevenin equivalent. Full one. And the load, 10 ohm load.
Better. You want the original circuit also?
No, we don't need that. Now we just want I2 of S, no?
I have in case if required.
Okay. We can do that. We can do that. But we want them to solve VTH of S, ZTH of S and the load.
Yeah.
Right? So
should I mark voltage source like this or?
That is fine. We can draw the voltage source like this, no problem.
So VTH was?
VTH, okay, I think I've forgotten. 1000 by S into S plus 20.
S square plus 30S. So this is a Thevenin equivalent.
Thevenin equivalent, and we have 10 ohm load. And the current through this is I2 of S, no?
So
by this one, S square plus 30S plus 100.
plus 10.
Plus 10.
So if you do LCM here.
Correct. Plus 10S plus 10S plus 200.
these two will get cancelled.
Correct. So
S
S
square
squared plus 40s plus 300.
Oh, I think we got the
We
same
got
thing.
the same. I think we have erased it.
Erased, no?
I think we have erased that portion because we decided to go a different route. I think we have erased that portion.
Or-
Yes, because we decided to do a plus
Correct,
we
correct,
delayed,
correct.
but that is right. So the denominator is s squared plus 40s
40s
plus 400 minus 100, 300.
300.
Correct. So that's what we have got here also.
Okay.
Same
Nice.
answer then, no?
Nice.
I2 of t will give you the
Nice.
same answer.
Nice.
Correct.
Anyway, I2 of t we don't have to.
So we don't have to do
already-
because it's the same. We have
Yeah,
already done
yeah.
it. And I think just to tell the students that now they learn more techniques, they can solve the same, problem in many ways.
Yeah.
Like I was thinking, we could have done. We have instead of finding VTH, VTH, ITH from between A, B,
Huh.
across this 100 by S in series with 10 ohm and S, no? That is already a voltage source in series with an impedance.
Yeah.
We could have converted that to a Norton equivalent source transformation,
Okay, okay.
right?
So this portion to a current source,
To a current source in parallel with an impedance.
10 ohm.
Then and then in parallel with that 10 ohm will come. You do back
Do
to
one more
voltage source, do
conversion.
one more conversion, you'll have the Thevenin equivalent, right? And in between we could have just considered S plus 10
this
as the load. So there are many different ways of simplifying your analysis, right?
It's up to their creativity.
Up to your creativity, correct. That is right.